Hello everyone. Today we are going to study a topic of reasoning called clock. So let us start the topic. So in a clock there are 12 partitions of hours. So let us draw a clock quickly. So now the first topic that we study in clock is angle between hands of clock. So the formula for finding angle between hands of clock is theta is equal to 30 into h upon minus 11 by 2 m in modulus, because angle can never be negative, where h is the hour and m is the minute. Suppose if I have to find the angle between hands of clock at 2:20, so we will, in place of h we'll put 2, in place of m we'll put 20. So my answer will be in modulus, so it will be 50 degree. Now let us see from where this formula comes. Now let us take example of 3 o'clock. There are 12 partitions in a clock and the complete angle is 360 degree. So we can say that 12 hour comprises of 360 degree, so 1 hour comprises of 30 degree. So at 3 o'clock we can clearly see that the angle here is 90 degree. Why it is 90 degree? Because there are 3 hours which are completed, so 30 into 3 gives us 90 degree. So we can clearly say that yes, the angle between hands of clock is 30h. But this is a standard case. Let us assume the second scenario where the time right now is 3:10. So now this theta, which is in red color, is the resultant angle between hands of clock. So at this time what will be the hands of clock? So earlier my angle was this whole was my angle and this whole angle was 90 degree, out of which this angle x degree got subtracted. This angle got subtracted due to movement of minute hand. So our minute hand is moving in clockwise direction along with the direction of our hand, and it is subtracting some angle which is here denoted by x degrees. So there are in one complete rotation of clock there are 60 minutes. 60 minute comprises of 360 degree, so 1 minute comprises of 6 degree. So our minute hand covers 6 degree per minute. So what is happening here, that out of 30h my 6 degree per minute is getting subtracted. But meanwhile, when the minute hand was moving in this direction, our hand was also moving a little in clockwise direction. So our hand was adding some angle and minute hand was subtracting some angle per minute. So minute hand was subtracting 6 degrees per minute. Let us see how much angle our hand subtracts. So there are 60 minute in 1 hour and 1 hour comprises of 30 degree. So in 60 minute our end covers 30 degree. So in 1 minute our end covers 30 by 60, which is half degree. So what is happening, that our end is covering 30 degree in 1 hour and our end is covering half degree in 1 minute. So when minute hand is moving in clockwise direction and it is subtracting 6 degrees per minute, our end is also moving and it is generating some angle which is half degree per minute. So I'll add half degree per minute in this. So this will now come out as 30h minus 6 plus half, which is minus 11 by 2. 30h minus 11 by 2m is the formula for angle between hands of clock. We have put mod because angle can never be negative. But why angle comes out negative? Because in this scenario, in this diagram, the more angle was covered by our hand and less amount of angle was covered by minute hand. But what if there is a scenario like this where the minute hand has covered more angle and hour hand has covered less angle. So in this scenario my formula has to be 11 by 2m minus 30h. So that is the formula for angle between hands of clock. Let us see a very good question based on this, based on the application of this. So let us take one example. A person goes to sleep between 2 to 3 p.m. and wakes up between 5 to 6 p.m. He observed that hands of clock have interchanged their position. At what time he slept? So let us draw two clocks quickly for this question. So so the person goes to sleep between 2 to 3 and wakes up between 5 to 6 in such a way that hands of clock have interchanged their position. So what is the mathematical interpretation of this? Mathematically it means that in both the scenario the angle between hands of clock is same. So approximately if I visualize the scenario, I can approximate that he would have slept around this time, around 2:25, and he would have woke up between 5 to 6 at around 5:10 approximately. So this is the time of going to sleep and this is the time of waking up from sleep. So what is happening here, that this was my R and sorry, in this diagram R and has to be a little shorter than the minute hand. So this is my minute hand and this is my R hand. So now what is happening, that this theta and this theta is same for these two conditions. So let us approach this question. So in this scenario, this theta and this remaining angle, which is 360 degree minus theta, in both the scenario, both the angle are same. So let us convert this situation in terms of time. We know that time is equal to distance upon speed. So the time required by this theta is equal to time required by 360 minus theta. Both the time is same. The time in which the minute hand has covered theta degree, the R hand has covered in the same time 360 minus theta degree. So let us equate these two scenarios in terms of time. But there is a catch. This minute hand has not come from here to here only at 360 minus theta degrees. Between 2 to 3, this has covered theta and this other hand has covered between 2 to 3, it has covered 360 degree. Then between 3 to 4 it has covered 360 degree. Then between 4 to 5 in this diagram it has covered 360 minus theta degree. So our minute hand has covered 360 degree between 2 to 3, then one complete rotation between 3 to 4 360 degree, then here it has covered the last rotation 360 minus theta degree. So the R hand is covering half degree per minute, so we'll divide it by half, and minute hand is covering 6 degree per minute. So here it becomes 13 theta is equal to, sorry, this will be 2 theta into 6, 12 theta is equal to 360 plus 360 plus 360 minus theta. This minus theta will come on this side and it will become 1080. yes, 13 theta is equal to 1080. So my theta angle comes out as 1080 by 13. So this was my time, approximate time, and the theta in this scenario is equal to 1080 upon 13. So let us find out the time. The question is asking us at what time he went out. So he went out between 2 to 3. So in this scenario we have to find m, and the h here is 2. So we will use this formula 30h minus 11 by 2m. Between 2 to 3 the more angle is covered by minute hand, so we'll use the formula 11 by 2m minus 30h is equal to 1080 by 13. 11 by 2m is equal to 1080 upon 13 plus 30 into 2, because h is 2. We have to find the minute at what time he went out. So 11 by 2m is equal to 1080 plus 780. So m is equal to 18, 16 to 2 upon 11. So this will be equal to 3720 upon 11. Let us divide it. Sorry, I made a calculation mistake. The denominator also has 13 in it, so it will be 3720 divided by 143. So let us divide it by 143. So 2 times 286. So 143 into 6. So that time is 26 whole 2 upon 143. So the person went out a little after 2:26. So my correct answer is 2:26 minute, and the second part is denoted in p whole q by r form. So this is my answer. So approximately we had guessed that it would be somewhat around 2:25, but we cannot guess it just by visualizing the diagram. So the correct time when he went out was 2:26 whole 2 upon 143. Suppose if the question is asking at what time the person came back, so the same angle will be used, and the formula used will be 30h minus 11 by 2m is equal to 1080 by 13, and in this case we'll put the value of h as 5. Thank you everyone.